Imagine the sun disappeared in this exact fraction of a second. No warning, no explosion, just an instant transition to a totally empty black void. Across a vast gap of 150 million kilometers, the sun's immense physical output provides the radiation that feeds terrestrial plants and the gravity that keeps our planet anchored in place. Yet, if it vanished right now, life on Earth would continue completely uninterrupted. The absolute speed limit of the universe, the speed of light, dictates how fast any information can travel through the vacuum of space. We are living on exactly 8 minutes of borrowed time, soaking in the final residual rays of a ghost star. For those 8 minutes, humans are still driving to work and harvesting crops, oblivious to the fact that their primary energy source no longer exists. Then the countdown expires. Complete, absolute darkness falls across the entire globe instantly, and there is absolutely no twilight. The moon and neighboring planets also vanish from the skies simultaneously. Because they rely entirely on reflecting the sun's rays, their light is extinguished, leaving only the faint glow of distant stars. The immediate blackout is terrifying, but it is a superficial problem. The real threat arrives at the exact same moment, the sudden loss of the sun's massive mass. Albert Einstein proved that gravitational waves travel through space at the exact same speed as light. This diagram shows the sun's gravity acting as a taut physical tether, holding Earth in a tight circular orbit. At the exact 8-minute mark, that tether vanishes. As we see here, Earth straightens its path, rocketing tangentially into deep space at our current orbital speed of 30 kilometers per second. Pulling back, the effect strikes the entire solar system. Every planet breaks orbit simultaneously, scattering on distinct straight-line vectors away from the center. Adrift in the void, Earth's surface immediately begins bleeding the thermal energy it accumulated over billions of years. Without a central mass to anchor it, our predictable biosphere rapidly converts into an icy, rogue projectile. By the end of the first week, surface temperatures drop to -17 degrees Celsius. Humans living near the equator could briefly endure this using heavy winter clothing. At the 1-year mark, average surface temperatures hit -73 degrees. Mass extinction wipes out terrestrial life, and the oceans begin to freeze solid from the top down. The massive gas giants, Jupiter and Saturn, fare differently. Their enormous physical mass creates intense gravitational compression, generating enough internal heat to stay warm without a star. We can see the effects of this gravity in this image of Jupiter's moon Europa. Beneath this fractured ice shell lies a massive ocean, kept entirely liquid by the intense tidal friction from its host planet. Europa proves a critical biological loophole. A liquid environment does not strictly require a star to stay warm. Jumping 1,000 years into Earth's dark drift, our surface temperature stabilizes at a brutal -240 degrees Celsius, near the ambient cold of deep space. However, life has not gone extinct. Biological activity persists, having retreated to the absolute bottom of the ocean floor. In this photograph of a deep-sea hydrothermal vent, you can see a thick plume of mineral-rich water erupting upward. These ecosystems rely on chemosynthesis, drawing geothermal energy directly from Earth's radioactive core, rather than solar radiation. Our planet becomes a self-contained biological life raft, using internal nuclear decay to power thriving ecosystems in pitch blackness. Zooming out to the galactic scale, the Sun was just one of roughly 400 billion active stars in the Milky Way. Traveling at 30 kilometers per second, Earth must drift in darkness for roughly 80,000 years before passing close enough to potentially enter the gravitational pull of a neighboring star, like Proxima Centauri. Astrophysicists refer to these starless wanderers as rogue planets. Recent models suggest billions of them are already drifting silently through our own galaxy. A central star is required to maintain a complex surface ecosystem, yet biological life itself is incredibly stubborn, capable of enduring the interstellar void like a dormant seed, waiting for the gravity of a new orbit to thaw.